VICTOG.com.
Next one is also an important proof on fundamental theorem of arithmetic. The question is, show that there is no any value of n. Show that there is no any value of n for which 4 raised to n ends with the digit 0, ends with the digit 0. We have to prove this only by logic statements. There is no other method of proving this. We have to prove that if we are giving the value n, we are giving different values for n. That is, instead of n, we are giving values 0, 1, 2, 3, 4, etc., etc. We are getting different numbers. None of these numbers will end with the digit 0. We have to show, we have to prove that with the help of fundamental theorem of arithmetic, that means by the method of prime factorization. We have to prove that. For that, we are writing the logics. That is, if the number 4 raised to n, if the number 4 raised to n, for any value of n, for any value of n, where to end with the digit 0, where to end with the digit 0, then it would be divisible by 5. That number would be divisible by 5. Then it would be divisible by 5. A number divisible by 5 means the prime factorization of that number must contain the prime 5. That is the prime factorization of, that is the prime factorization of 4 raised to n would contain the prime 5. Would contain the prime 5. That is, if the number 4 raised to n must end with the digit 0, then that number must be divisible by 5. That is, 4 raised to n on factorization would contain the prime 5. This is not possible because this is not possible because 4 raised to n is equal to 4 can be expressed as 2 raised to 2 the whole raised to n. 4 is equal to 2 raised to 2. Therefore, 4 raised to n is equal to 2 raised to 2 the whole raised to n, which is equal to 2 raised to 2n. 2 raised to 2n. So, the only prime, therefore, the only prime in the factorization of 4 raised to n is 2. We are getting the only prime 2 in the factorization of 4 raised to n. The only prime in the factorization of 4 raised to n is 2. So, by the uniqueness of fundamental theorem of arithmetic, therefore, by the uniqueness of fundamental theorem of arithmetic, so by the uniqueness of fundamental theorem of arithmetic, there is no other primes in the factorization of 4 raised to n. There is no other primes in the factorization of 4 raised to n. So we can conclude that there is no natural number n. Therefore, there is no natural number n. No natural number n for which 4 raised to n can end with the digit 0. End with the digit 0. This is the proof. Once again, we have to prove that there is no value of n for which 4 raised to n can end with the digit 0. The logic is, if the number 4 raised to n can end with the digit 0, then it must be, that is 4 raised to n must be divisible by 5. If we are giving any value for n, 1, 2, 3, 4, etc., that is 4 raised to 1, 4 raised to 2, 4 raised to 3, 4 raised to 4, etc., the number obtained on giving different values for n will end with the digit 5. Then only we can divisible by 5, or it would end with the digit 0, 0 or 5. Then only we can say that it is divisible by 5. The prime factorization of 4 raised to n would contain the prime 5. That means this is not possible because 4 raised to n, the only prime factorization of 4 is equal to 2 into 2, which is equal to 2 square. Therefore, 4 raised to n is equal to 2 square, the whole raised to n, which is equal to 2 raised to 2n. This is the only prime factorization of 4 raised to n. That means the only prime in the factorization, the only prime occurring in the prime factorization of 4 raised to n is 2. Therefore, by the uniqueness of fundamental theorem of arithmetic, we can say that there is no other prime number in the prime factorization of 4 raised to n. So, there is no natural number n for which 4 raised to n can end with the digit 0, and this is the proof of 4 raised to n cannot end with the digit 0 for any value of n. So, it's also an important proof. Note it as an important question. Okay.